Good evening, everybody. Welcome to day one on week 6 of the semester. Now we are going to get started to just do a little recap on the last topic that we talked about in class last week. So last week, the last topic was just the introduction of what are organic compounds. When it comes to organic compounds, understand that these are going to be compounds that at the center of it, all of them are going to have a carbon atom. Then carbon atom is going to be combined with other nonmetals like hydrogen, oxygen, sulfur, nitrogen, phosphorus, or a halogen. So because we have groups of nonmetals which are going to be combining in order to make these organic compounds, understand that that's why they have covalent bonds. Now, when we compared organic compounds to ionic compounds, they tend to have lower melting points and boiling points. Organic compounds are not soluble in water. So the majority of them, there are that are soluble, but we will talk about which ones are soluble and in which instance they are. But the majority of them are not. So that means that a large number of organic compounds are going to be non-polar molecules. Now, we find organic compounds everywhere, in gasoline, in medicines, in shampoo, in plastic, perfumes. As you can see in the bottom right corner, plants have organic compounds, animals have organic compounds, our food has organic compounds. The clothes that we have, the shoes that we have, many of the materials inside of cells, materials that are utilized to make the substances around us, all of those have organic compounds. Now, when it comes to organic compounds, it is important to note that organic compounds have what are called functional groups. And functional groups are going to be just certain signatures that depend on how the atoms are attached, that we will know if this particular signature, or what we call in chemistry motif, pertains to a functional group, okay? So this is just the main characteristics, the main families of compounds that are considered organic compounds. That's basically what a functional group is. Give me a moment, because this disconnected. Okay, now it's working again. So when it comes to these organic chemistry functional groups, understand that for exam number 2, it is important that you know how to identify them. I have broken down all these functional groups that exist in organic chemistry by families. So at least it will be a little bit easier to identify. So let's go through the different families of functional groups, starting with hydrocarbons, okay? So if a functional group is called a hydrocarbon, let's put in the chat, what are the two elements that you think make up those atoms? If it's called a hydrocarbon, based on the name, what are the two elements? Great job, exactly. Hydrogen and carbon. So these elements are going to have in their structures hydrogen and carbon atoms. Now, there are four members of the hydrocarbon family, starting with alkanes. So when you have an alkane, alkanes are symbolized by having carbon-carbon single bonds and carbon-hydrogen single bonds. That's what makes an alkane. Then we have an alkene. An alkene is going to have one or more carbon-carbon double bonds. Then we have an alkyne. In an alkyne, we're going to have one or more carbon-carbon triple bonds. And lastly, we have an arene. And when it comes to an arene, arenes are very particular. You need to have, give me one moment. You need to have a hexagon with alternating double bonds and single bonds. This structure of a hexagon with alternating double bonds and single bonds is what we know in organic chemistry as a benzene ring. So as long as the molecule has that hexagon with alternating double bonds and single bonds, that is known as an arene. Let's now move to the family of heteroatomics. Heteroatomics basically means that we're going to have other atoms than carbons and hydrogens in our structures. So when it comes to the heteroatomics, as you can see, the first member in this family is going to be an alcohol. Now, one of the things that you guys will get used to is that in organic chemistry, at times you're going to see that R, okay? And R is not an element, it's not in the periodic table. What R represents is the rest of molecule. At times, R is going to be a carbon atom. At times, R is going to be a hydrogen atom. So in the case of an alcohol, what we know we have here is that R is going to represent a chain of carbons and hydrogens, okay? So as long as you have attached to a carbon atom an OH group, that's considered an alcohol. The next member of the heteroatomics family is an ether. In an ether, notice that on either side, it has R groups. And in the case of an ether, each side of that single bond oxygen needs to have carbon chains that then they are attached to other atoms. But we must respect that carbon follows the octet rule. So carbon is always going to have 8 electrons around itself. So an ether is going to be an oxygen atom that on either side, it has carbon chains. Then we have a haloalkane, which is also known as an alkyl halide. So when it comes to an alkyl halide, that R is going to represent a carbon chain. So let me just make sure that you guys have here. R is a chain of carbon atoms for any of these. So whenever you have a carbon chain that is bonded to a halogen, okay, which is represented here by the letter X, this is going to be a halogen. Meaning anybody in 7A, fluorine, chlorine, bromine, iodine, when it's attached to a carbon chain, that is known as a haloalkane or an alkyl halide. Two more members of the heteroatomics family. The first one is an amine. And when it comes to an amine, understand that R is still a carbon chain. And then as long as that carbon chain is bonded to nitrogen, okay? In here, we are representing an amine with an NH2. But as long as you have a nitrogen, that is representing an amine. When a carbon chain, or an R group, is bonded to an SH group, that is known as a thiol, okay? And those are the members for heteroatomics. Now, in the textbook, let me just emphasize it here. In the textbook, there's one more member of the heteroatomics, which is going to be a phosphate group. So this phosphate group is when you have an R group bonded to a PO4 group. That is a phosphate group. And that is also part. The reason why phosphates are included here is because that is an important functional group in biological systems. Any questions so far on the hydrocarbons or the heteroatomics? Then let's move on to the next family, which is the carbonyl group, okay? So what is a carbonyl group? A carbonyl group is going to be a carbon that is double bonded with oxygen. Carbon double bonded with oxygen. So that's why all of these functional groups are known as containing carbonyl groups. Now, it is important to know that the difference between them is going to be based on what is attached in this carbonyl group, okay? So remember, R in the previous functional groups, it was carbon chains, okay? So for these, I'm going to specify what R is. So remember, R is the rest of molecule. So how do I know that I have an aldehyde? Because I have a carbonyl group that is attached to hydrogen on one side, and then the R group can be an H, meaning a hydrogen, or a carbon chain. So for example, if I have the molecule C double bond O H, and it has an H to the other side, that is an aldehyde. But if I have a C double bond O, H on one side, and a CH3 on the other side, that is also an aldehyde. Okay, so as long as you have a carbonyl attached to a hydrogen to one side, it's going to be called an aldehyde. Then we have the ketones, okay? So what is a ketone? A ketone is when I have a carbonyl, and then you have two R groups on either side. For a ketone, the R group must be carbon chains. So on either side of the carbonyl, you must have carbon chains. So for example, if we have a C double bond O, and on this side it has two carbons, and then on this side it has one carbon, overall that is considered a ketone. The next member of the carbonyl family is going to be a carboxylic acid. And when it comes to the carboxylic acid, the C double bond O is bonded to OH to one side, okay? In carboxylic acids, the R group can be hydrogen or a carbon chain. Meaning that if I have this, or if I have this, they are both carboxylic acids. Please don't confuse the first molecule and say like, oh, that's an aldehyde and a carboxylic acid. No. Overall, the minute that you have a C double bond O with an OH, that's a carboxylic acid. Let's move on to the last two members. The next one is an ester, okay? When it comes to the esters, we have a carbonyl group that is bonded to oxygen via a single bond, and that oxygen must be bonded to an R group. Now, I'm going to make distinctions about the R group that is bonded to the single bond oxygen. So I'm going to call them R1 or R prime versus the one that is to the other side of the molecule. So in the case of an ester, understand that the one that is just R, that can be hydrogen or a carbon chain. The one that is labeled R prime, the one that is connected to the single bond oxygen, that must be a carbon chain. Because overall, understand that in order to have an ester, you need to have a single bond oxygen bonded to a carbon atom with whatever is attached to it. It could be more carbons, it could be hydrogen. So, for example, this is an example of an ester, simply by the fact that we have a C double bond O bonded to a carbon chain. That's what makes it an ester. The last member of the carbonyl family is going to be an amide, okay? And in order for something to be considered an amide, we need a carbonyl bonded to a nitrogen atom, and that nitrogen atom can have two hydrogens, it could have carbon chains, but specifically having C double bond O and And nitrogen also has an octet. It's just that it has a lone pair. So typically we see 3 things attached to nitrogen in a lone pair. But having a C double bond N symbolizes that we have an amide. The R group on an amide can be hydrogen or a carbon chain. Any questions on any of the members of the functional groups that I just showed? One important skill that you guys need to get out of this whole thing is if I give you an organic compound, we need to identify the different functional groups that are present there. So I gave you guys a little sample of just different compounds that you may have heard, but I gave you the chemical structures for them, okay? And right now we're going to identify the functional groups in the following organic compounds. So I'm going to do the first one that is on the first row towards the left, and this is acetaminophen. So acetaminophen is one of those pain reliever medicines that you can utilize. And this is the structure of acetaminophen. So when I look at the structure of acetaminophen, I will identify that it has, I'm going to use my highlighter tool. It has a hexagon with alternating double bonds and single bonds. And it needs to be in that order: double bond, single bond, double bond, single bond, double bond, single bond. That is known as an arene. Now, each one of the atoms here is a carbon. So as you can see, there's an OH attached to that arene. So what that means is that overall, this corner of the molecule, because there's a carbon atom bonded to an OH, this is an alcohol. When I look throughout the molecule, what other family of functional groups can I see? From the ones that we just discussed. I hope that you guys can identify that here we have a carbon that is double bonded to oxygen. Remember that the double bond needs to be carbon and carbon, and here we have an oxygen on the other end. So we have a carbon atom right here that is double bonded with oxygen, and to one side of the molecule is bonded to nitrogen. So whenever we have a carbonyl bonded to nitrogen, that is called an amide group. Okay. Let's look at the following structure, because I want you guys to get practice with this. Okay, the molecule in the bottom. I'm going to write in the carbon atoms because I think that's going to help a number of you. So there's a carbon atom right here. There's a carbon atom right here. There's one right here, one right here, one right here, one right here. There's a carbon atom right here. This has a hydrogen. This has hydrogen. Okay. So this is the structure of vanillin. Okay. Which is the one that gives rise to the taste of vanilla. Okay. So when we look at the structure of vanillin, let me zoom in. Here I have a carbon atom bonded to OH. What is that functional group? When a carbon atom is bonded to OH, let's put it in the chat. Thank you, Maria. Exactly. That is an alcohol. Now, here we have a hexagon with alternating double bonds and single bonds. What is that called? Thank you, Katie. Yes, this is called an arene. Next, we have in this molecule a carbon atom bonded to oxygen, bonded to a carbon chain. So when I have an oxygen bonded to two carbon chains, what is that called? An oxygen atom, sorry, bonded to two carbon chains. Thank you, Vanessa. That is called an ether. And lastly, I have a carbon atom double bonded with oxygen, and to one side, it has a hydrogen. Not quite the ketone. Thank you, Kiyomi. That is an aldehyde. Put a 1 in the chat if you want to practice at least one more structure. Put a 2 in the chat if the highlighting helps. Okay, just want to make sure. Here we have a structure, which is just one of the derivatives for vitamin B6, okay? So I want to add some atoms because we still haven't talked about in detail where carbons are. So I want you guys to know there's a carbon atom right here, bonded to a hydrogen. There's a carbon atom right here. There's one right here. There's one right here. This is a CH3. This is a carbon bonded to hydrogen. This is a carbon. This is a carbon bonded to two hydrogens, okay? We're going to learn how to determine the carbons and all that kind of good stuff. It's just that for now, I'm writing them for you guys. So let's go through the following structure. Starting with the top, I have a carbon double bonded with oxygen, single bonded to a hydrogen. What is that called? Great, thank you, Kiyomi. That is an aldehyde. If I have a carbon atom bonded to OH, what is that called? Thank you, Vanessa. Exactly. That is called an alcohol. And you can see that we have two of them. We have one on this corner too. Now, I want you guys to pay attention to something here, because I don't want you to always look at the hexagon and be like, oh, that's an arene. Notice that here, not every atom is carbon. We have a nitrogen within this 6-ring system. So that automatically does not make it an arene. There are only 2 functional groups that have hydrogen in it: an amide and an amine. Amides are connected to a carbonyl. Amines are not. So if we utilize that reasoning, which one is this? Is this an amine or is this an amide? So is this an amine or is this an amide? Great job, Maria. Exactly. This is an amine. Again, amine, because if you have a nitrogen atom bonded to carbon chains, that is considered an amine. In order for something to be considered an amide, it has to be a nitrogen atom bonded to a carbonyl, okay? So I'm going to give you guys a couple of minutes. Look at the structure of jasmonate. Jasmonate is the molecule responsible for the odor of jasmine, okay? So whenever you smell jasmine flowers, which is very soothing, I don't know who's with me with it, but for me, jasmines, it reminds me of my grandma's garden, and it's one of my mom's favorite flowers. So this compound is, oh, thank you, Katie. This is the structure that is responsible for that smell, okay? So I'm going to give you guys a couple of minutes. I'm going to include the carbons that you guys cannot see, so at least you have a reference, and then we're going to discuss what are the functional groups in jasmonate. So I'll give you guys a couple of minutes. Okay, let's get started with this molecule. Let's first determine what is the functional groups that is given by carbon being double bonded to another carbon. What is the functional group when we have a carbon-carbon double bond? Great job, you guys. Exactly. That is called an alkene. Then, this corner of the molecule has a carbonyl group bonded on either side to carbon atoms. So when I have a carbonyl group bonded to carbons on either side, what is that called? Great, a ketone. And thank you for spelling ketone correctly. Ketone does not have a Y. It's Ketone. So this is a ketone. Now, when it comes to this molecule, we also have here a carbonyl that is single bonded to oxygen, and that oxygen is bonded to a carbon chain. So when we have a carbonyl with a single bond oxygen, and that oxygen is bonded to a carbon chain, what's that called? Excellent. That is an ester group. Any questions identifying functional groups in molecules? Great. So just make sure that you know how to identify the functional groups when it comes to exams, quizzes, chapter quizzes. There are different types of ways in which we can, in which I can ask you this. I will give you the molecule and then I circle the functional group, so the atoms in the functional group, and then I ask you what are the functional groups. The other way that I ask this question is that I just give you the molecule and then I list the different functional groups, and then you select the correct group of functional groups depending on the molecule. So be aware of that. Since there are no questions, now let's move on to section 4.4. In section 4.4, we are going to be looking at the nomenclature of simple alkanes, okay? So earlier in this chapter, we learned that alkanes are going to be the family of hydrocarbons that contain only carbon-carbon single bonds and carbon-hydrogen single bonds, okay? Now, when it comes to alkanes, let's understand that alkanes can have a continuous chain of carbon atoms. And if we go back to something that we mentioned last week, you can see that in this table, which is not in your textbook, but understand that there is a similar table in your textbook. It's just that is given in terms of stretching the atoms out. So they give you the expanded formula. These are the condensed formulas for these. But we learned last week that we can have names for the different straight chains of carbon atoms, and depending on the number of carbons, we have a prefix that is attached to that number of carbons. The main ones that you guys have to memorize is 1 through 4, meth, eth, prop, and bute, because from 5 to 10, they are all Greek prefixes, okay? So why does that come in handy? Well, because we are going to see alkanes, and alkanes can be in straight chain, okay? So as you can see here, we have a straight chain of alkanes, okay? We have 4 carbon atoms. What is the prefix for 4 carbons in a row? Let's put it in the chat. Great, is bute, and because it is an alkane, the name of this molecule will be butane, okay? But what happens if our alkane, now it has groups that are extending from the longest continuous chain? So for example, if we look at this molecule below, we can see that specifically the longest continuous chain of carbons will be from here to here. Or you can also select from here to there. It doesn't matter which one of the two you select, regardless on every direction, left to right or left to right and up, we have 3 carbons in a row. So when our continuous chain is 3 carbons in a row, what is the prefix for 3 carbons and the ending, because we have an alkane? What will be the name of what I highlighted in green? Awesome. That is propane, because there's 3 carbons in a row. Now, we have to actually give a name to that group that is outside. And that group that is extending from the longest continuous chain, this is called a substituent. And as you can see, a substituent by definition is going to be an atom or group of atoms that is arranged as a side group, or we also call them branches, okay? So which ones do you guys need to know? They are summarized in this table. This table is not from your textbook, but you can see the list of substituents that I'm going to hold you guys responsible for. As you can see from our image, we have a substituent that is a CH3. When we look at this table, we see that a CH3 group is called methyl. So to symbolize that we have a branch, we're going to put that before the longest chain of carbon. So we're going to say, oh, I have a methyl group in front of within my propane. And then we're going to give it location. So if I number this 1, 2, 3, then I can say, hey, at carbon 2, I have a methyl group within my propane, longest chain, okay? So, as you can see here, when it comes to the formulas and the substituents, when we have a CH3 extending out of the longest continuous chain of carbon, that is called methyl. When we have a CH3, CH2, that is an ethyl group. When we have a CH3, CH2, CH2, that is a propyl group. If we have 3 carbons in a row, but then now the connection is through the middle one, that is called an isopropyl group. And lastly, if we have a haloalkane or an alkyl halide, meaning that we have halogens as substituents, as you can see, fluoro is for fluorine, chloro is for chlorine, bromo is for bromine, and iodo is for iodine. Okay, so we're going to go step by step when it comes to naming. The first thing that we're going to learn how to name is, what if I have an alkane with 1 substituent? Okay, it doesn't matter what functional group we're trying to name, you guys. The first rule is always the same in organic chemistry. You're going to find the longest chain of carbon atoms that is connected continuously in any direction. It could be left to right, it could be left to right up, it could be you start at the left and then it points down. It has to be in any direction, okay? So if we look at the molecule that is in the top, remember that that is called a condensed molecule because my carbon atoms and my hydrogens are illustrated, okay? So when I look at the longest continuous chain of carbon atoms in this molecule, I have specifically these carbon atoms as my longest continuous chain, okay? How many carbons do I have here? Great, 8 carbons, okay? As you can see here, you're going to write the alkane name for the longest continuous chain. So what would be the word that tells me that I have 8 carbon atoms in a row? Great job, exactly, octane. Now, we have to count the carbon atoms from the end that is that is nearest a substituent, okay? So what will be carbon 1? Will it be this end or would it be this end? Meaning the one on the left or the one on the right? What should be my carbon 1? I need to start numbering my carbon chain starting from the end that is nearest a substituent. So would I pick left or right as carbon 1? Excellent job, right. So that means that this is carbon 2, this is carbon 3, this is 4, 5, 6, 7, 8. The reason why we have to do it that way is because in our substituents, we want to give them the lowest number, okay? So as you can see here, we have one branch. This branch is a CH2 connected to a CH3. So what is the name of that branch? A CH2 connected to a CH3. Great, that is called an ethyl group. So as a prefix of my parent chain, I'm going to give the name of the substituent, ethyl, and its location, which is 3. So the name of this compound is 3-ethyl octane. Here I have a skeletal structure, okay? I'm going to find the longest carbon chain of atoms. There's a carbon right here, one 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 right here. Remember, in a skeletal structure, my hydrogens and my carbons are not illustrated. Well, at least the hydrogens that are bonded to carbon. So, how many carbon atoms are in this skeletal structure? Great, there's 6. What is the alkane name for a continuous chain of carbon that has 6 carbons in a row? Great, you guys are getting the hang of it. This is hexane. Now, when I number this, remember, I have to go from the end that is nearest a substituent. So, would the one on the left is number 1, or would the one on the right is number 1? Great, the one on the left. This is 2, 3, 4, 5, 6. So in this molecule, our substituent is a Cl group. What is the word that we can utilize when we have a branch or a side group or a substituent that is chlorine? What's the word? Great, chloro. So we have a chloro group, okay? And then we give the location of the chloro group. At position 2, I have a chloro group. Notice that numbers and letters are always separated by a hyphen. Always. Numbers and letters are separated by a hyphen. So the name of that bottom molecule is 2-chlorohexane. Let's practice. As you can see, we have in the top row a series of molecules that are in condensed structures. And in the bottom, we have a series of molecules that are in skeletal structure. So I want you guys to practice this molecule, this molecule, this molecule, and this molecule. So we're going to do from the first row, number 2 and number 3, from the second row, number 1 and number 3. Okay? You're going to find the longest carbon chain. Then you're going to number the chain starting the end that as near as a substituent. Then you're going to name that substituent, and that's going to be the prefix of the longest carbon chain, and then you're going to give its location. So I'll give you guys 3 minutes to do these 4 problems. Okay, let's get started. Middle molecule on the first row, okay? How many carbons on the longest continuous chain of carbons in this molecule? People say 3. Somebody said 4. The correct answer is 4. I know that you're tempted to say, oh, these 3. But look, the longest continuous chain is this. When it comes to alkanes, you're going from CH3 to CH3. So instead of going straight across, you can actually go to the right and down, and that's 4 carbons. Since that is the longest chain of carbon, what is the name of that chain? Which is also known as the parent chain or the functional group. What's the name of that? Great, thank you, Katie. This is butane. Then we have to select to number this from the end that is nearest a substituent. In this case, we have to say 1, 2, 3, 4. Let me use a different color so you guys see the difference between the two. If I go 1, 2, 3, 4, you can see that in the blue numbering, oh, my substituent is on 3. No, the end that is nearest a substituent is the one, the CH3 that is all the way to the left in the top. So then this means that this blue numbering is not correct. So here we have one substituent, which is this one. If you have a CH3 as a branch, what is that called? Great, that's a methyl group. And that methyl group is on position 2. And because there's a number and there's letters, we separate them by a hyphen. So the name of this molecule is 2-methyl-butane. Let's move on to the next molecule. What is the number of carbons in the longest carbon chain, you guys? How many? Let's put it in the chat. Excellent job, 5. So I need to start numbering this from the end that is nearest a substituent. So I'm going to go 1, 2, 3, 4, 5. So the name of my functional group, parent chain, basically the longest continuous chain, since I have 5 carbons. Yes, thank you. 5 is pentane. My branch here is going to be Br. So if I have a bromine as a branch, as a substituent, what is the name of that substituent? Great job, excellent. Bromo. And then as a prefix of that, I give its location, which is 2-bromopentane. Let's move on to the skeletal. What is the longest carbon chain on that molecule? The first molecule on the second row. How many carbons? Ooh, the house is divided between 7s and 8s. Again, longest continuous chain. We're going in terms of a alkane from CH3 to CH3. The correct answer is 8. Because we will go 1, 2, 3, 4, 5, 6, 7, 8. That is the longest continuous chain of carbon atoms. Great job. Thank you, Katie. Yes, because we have 8 carbons, that means that the name is going to be octane. Now, when I number this, I have to go 1, 2, 3, 4, 5, 6, 7, 8. Because if I do it in the other direction, then my substituent is going to have a value of 5. And I need to give it the lowest number. So my substituent here is a carbon atom bonded to another carbon atom. So that's my substituent. What is the only substituent that we have on the table that I told you guys that is important that you know that has 2 carbon atoms? What is that called? A CH2CH3. That is an ethyl group. And then my ethyl group is on carbon 4. So the name of this molecule is ethyl octane. For those of you that have a hard time looking at a molecule that's skeletal and be like, you know what, Dr. Luz, I don't know what you're talking about. It's not complicated to go from skeletal to condensed, just in case if you need to see the carbon atoms, right? Let me just do the transformation with this molecule. So here I have a skeletal structure, okay? So every time, let me just use a different color. I'm going to start with a carbon atom. Every vertex is a carbon atom. Every end is a carbon atom. So there's a carbon right there. There's a carbon right here. There's a carbon right here. And there's a carbon right here. Those carbons have hydrogens. How do I know how many hydrogens they have? Because carbon must have 4 things attached to it because it needs 8 electrons. So if I look at the first carbon atom, okay? This carbon atom is already bonded, okay, to a single bond. So that means that it needs 3 lines. Those 3 lines will be filled like hydrogens. So that means that that first carbon is known as a carbon with 3 hydrogens, okay? So don't confuse that CH3 with a branch CH3, okay? Because this is going to be the longest continuous chain. The methyl groups, ethyl groups, propyl groups, isopropyl groups are going to be branches extending out from the longest continuous carbon chain. So following along, carbon number 2, because it's bonded to 3 lines, this one, and this one, only needs 1 hydrogen atom to complete its octet. How many hydrogens? Let's put the number of hydrogens. How many hydrogens does the next carbon need to complete its octet? Great job, 2. So this is a CH2. What about the last carbon? How many hydrogens? Great, 3 hydrogens. So this is a CH3. So as you can see, if you're given skeletal and you feel a little bit intimidating, no worries. Change your skeletal to condensed and then go ahead with your naming. Really quick, what would be the name of this compound? 4 carbon atoms in a row as our longest carbon chain. We have a substituent on carbon number 2, which is a bromine. What would be the name of this compound? Excellent job. This is 2 bromobutane. Let's do the last example that we have here. Okay. What is the longest carbon chain, the longest continuous chain of carbons that we have in this molecule? Let's put the number in the chat. I agree with that. 8 carbon atoms. There's a carbon right here, one 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 right here. That's our longest carbon chain, okay? So since there's 8 carbons, what's going to be the name of that long chain of carbons, AKA the parent chain, the functional group? What is the name? Great, that's octane. We have to number this from the end that is nearest a substituent. Here we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Taking that into consideration, we have on carbon 4 the following branch. This branch is composed of 1, 2, 3 carbon atoms, but the carbon atoms are bonded through the middle carbon. So if we go back to the table that we have for substituents, what is the name of this substituent? 3 carbons in a row, but then we're attached in the branch in the middle carbon. If we look at the order of atoms, this is a CH3, CH, CH3. What is that substituent? Thank you, Marisol. That's isopropyl. And on carbon 4 is where we have it, okay? Any questions on alkanes with one substituent? In addition of going from structure to name, which is what we did right now, for lab 3B, you guys need to be able to draw the condensed structure and the skeletal structure, okay? For specifically any compound that you are given, okay? So if you're given the IUPAC name, as you can see here, I'm going to do the first example with you guys, and then as a group, we're going to do the second one. I have the following compound, 1-chloropropane. So when I need to draw the condensed structure and skeletal structure for it, this is how I develop them. First, I'm going to draw the longest carbon chain. So what word in the name gives me that? The very last one, the propane. Okay. Propane is not 5. How many carbons in propane? Great, 3. So I'm going to do 1 carbon, 2 carbons, 3 carbons. Then you can see that it says on carbon 1, I have a chloro group. So what would be the symbol for that substituent that I have on carbon 1? What is the symbol? If I have a chloro group, excellent. I have a Cl group. Because I'm drawing the condensed, then I need to fill the rest of the molecule with hydrogens. Again, respecting that carbon atoms follow the octet rule. Carbon only wants to have 8 electrons around it. So when I look to the molecule, the first carbon that is holding the Cl already have bonds to 2 atoms, the chlorine and the neighbor carbon. So that means that it's going to get only 2 hydrogens. What about the middle carbon? How many hydrogens will it get? Let's put it in the chat. Great, also 2. What about the last carbon? Excellent, it gets 3 hydrogens. Now, what do I do with the skeletal? When it comes to the skeletal, understand that I advise my students from Chemistry 112 that I do not mind if you guys use dots to symbolize the carbons. This is what I mean. Technically, if we're going to do a traditional skeletal structure, the minute that your utensil touches the paper, that's carbon 1, and then you move in an angle up to carbon 2, down to carbon 3, okay? So that's traditionally what we do. But for students in Chemistry 112, I do not mind if you guys say, okay, this is carbon 1, I move up to carbon 2, down to carbon 3. Because I think sometimes that circle really helps students to understand the carbons that are in it. What I do not want to see when you guys do the skeletal is that you do squiggly lines, because I can just count a whole bunch of carbons there. So just make sure that you are intentional about those circles and lines. And remember that it's always the minute that your utensil touches the paper, that's carbon 1, and then you move up, that's carbon 2, and then down carbon 3, and then you go depending on how many carbons. So this one only has 3. Now, carbon 1 needs to have a chlorine, okay? So when it comes to this, technically, with the correct bond angle, we should draw the chlorine this way. But understand that if you give me answers that look like this, I will still accept them. The first one is showing the correct angle because those carbons are tetrahedral, but I will take the second answer also, okay? Let's move on to the next one. 2-Iodo Pentane. How many carbons in the parent chain, meaning in the longest continuous chain of carbon atoms? Great, there's 5. I draw 1, 2, 3, 4, 5. So I have an iodo group. What is the symbol for that iodo group? Great job, a capital I, because that's iodine. Now, I think you guys got this. We're going to use the chat to actually put in how many hydrogens I need to put on each of these carbon atoms for the condensed structure. So the first carbon, how many hydrogens does it get? Help me out, you guys. There you go. Excellent. 3. What about the second carbon, the one that is holding the iodine? How many hydrogens will it get? Oh, you guys are going to do so well in that second exam. Exactly. This is only 1 hydrogen. What about that third and fourth carbon? They have the same number of hydrogens. Great. This is a CH2. This is a CH2. What about the last carbon? I always find, you guys, that when it comes from name to structure, those are easier because it's up to you how you draw it out. Always going from structure to name is a little bit more challenging just because you need to find the longest carbon chain. But I know that you guys are going to practice and you're going to master this skill. So next, we have to draw the skeletal structure. So we're going to do carbon 1, up carbon 2, down carbon 3, up carbon 4, down carbon 5. Now, out of carbon 2, we're going to do a bond to the iodine. For those of you that are wondering, why is it that Dr. Luz drew it to the side? It's because when we have alkanes, each one of the carbon atoms is going to be tetrahedral. So it has an angle of 105.9. So technically, that's how the iodine will look like. Now, if you guys give me structures that look like this, or even if you drew it like this, I will take it as a right answer. Just because you're illustrating to me that you know that there's 5 carbons in a row and there's an iodine on carbon 2. Okay? So just be aware of that. But in general, as long as you know how to draw them, the only thing that I do not give credit to is that if in the skeletal structure, you show the carbons and you show the hydrogens attached to the carbons, because technically in the skeletal structure, we don't need any of that, okay? Any questions going from structure to name or name to structure for alkanes with 1 substituent? Okay, since there are no questions, when we get back on Thursday, we are going to learn how to name alkanes where 2 or more of the same substituent, how to name alkanes with multiple substituents that are different, and then we're going to proceed to name other hydrocarbons, okay? So that's all for today, you guys. Thank you so much for coming.